Guys, what is up? Welcome back. We're ready for part 2 of the review. We're doing page 2 now. Ignore me as I move the camera. Yes, that way. And then this way. Perfect. Okay, we're on page 2 now. It's really, really similar to the page we just did. Now, same thing. I'm going to do a couple for us. And then we will actually... I will let you do the rest on your own. I would really like for you to do these on your own. You need to practice. Practice mathematics is the best way to learn. It's just like any skill. So, in this case, we're going to see each pair of triangles state a postulate or theorem that can be used to conclude the triangles are congruent. All that means is here, using a postulate or theorem, it means we're thinking of our side, 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 angle, side, angle, side, angle, 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 side, hypotenuse, leg. That is all of them that we have for congruence. So, you can't see that. Those are the ones we're thinking of whenever we're doing stuff like this. So, down here. Now, this is a little bit different than the last page because the last page, all it asks you to do is kind of name, you're assuming they're congruent and you're kind of just naming them. In this case, if they are congruent, we have to justify it using the theorem. So, anyways, the reason that's different. Now, it doesn't say to state any congruency relationship. So in this case, we're not writing like, triangle ABC is congruent to. We're not doing that for this problem. All right, now, number 1. We need to come up with one of the theorems that we could apply in order to show that these two triangles, this one and this one, are congruent. The best way to do that, in my opinion, is by realizing this segment GI is reflexively equal in both triangles. Since it's present in both triangles and it is the same as itself, we would say GI is congruent to GI reflexively. And so we have a side, angle, side relationship. A side touching an angle touching a side. Okay, and that's true for both of these triangles. And since that is a valid method, of proving congruence using a theorem, we would say this is a side, angle, side congruence problem. All right. Same thing, but for number 2, I notice a very similar reflexively equal side. So I'm going to give it 3 hash marks here. Now, I don't know if this is normally done. I'm just doing this visually to show you guys. I'm trying to demonstrate these are the 3 sides that I'm talking about. So I see side, side, side congruence in this case. So I'm going to write that down. Side, side, side. Beautiful. That's all for number 2. On to number 3. This one's a little more involved. So here I see I have an angle equal. So I got an angle corresponding. I got a side corresponding in these 2 triangles. All right. Now there's a bunch of ways I could do this. I actually do know the only one that doesn't work, SSA, side, side angle, that one does not work, just so you know. All right. We see if I was going to add another side somewhere, I would be left with angle, side, side. Okay, unless it was this side, which I don't know to be true. So the result is I'm going to use an angle instead. Now, I do notice immediately the angle BCA is congruent to the angle DCE, or really I should say ECD. All right? Those angles are congruent because they are a vertical pair. Sorry about the handwriting. That was a weird paper fold. The vertical pair, since these guys are vertical pair, they are definitely congruent, meaning they're corresponding in both triangles. Therefore, by angle, side, angle congruence, these triangles must be equal. So angle, side, angle is the answer I would put for number 3. Now, I'm going to skip number 4 and jump down to number 5 because I just like talking about math. Now, number 4 I think you guys can do using the same kind of properties I'm doing. I notice immediately these 2 triangles in this case share the line KM. So it's reflexively equal in both triangles, meaning it corresponds to both triangles. Beautiful. Now I have a corresponding angle, corresponding side. So this looks like, now I need to jump to the closest thing in this case. So if I'm jumping to the angle, right, these angles are as close as they could be, angle, angle, side. This makes it an angle, angle, side problem because the side lies outside of the 2 angles. It's not between the 2 angles. That's the distinct difference here that we just saw from angle, side, angle. So in angle, side, angle, the side is between the 2 angles, and that's given in the notation. The side is between the 2 angles. In this case, the side is not. It's outside of the 2 angles, and so that's why we put the S out here in angle, angle, side. That's a distinct difference between those two. Now, skipping all these, I'm going to go down to 11 because it's caused a bit of a confusion. I don't know if there's a problem on the review or if it's just meant to be like this, but I'm going to show you guys the basics. So, same thing we've been doing. I'm going to apply the same knowledge that I've had. In this case, I see a reflexively congruent side, KM, is congruent in both triangles, making it a corresponding side for these two triangles. Now, the problem is, even though that this angle and this side and this angle all correspond, it's not an angle-side angle. What's the problem? There's a side, and an angle. Okay? Now, if I was going to write this in notation, I would write my two sides next to each other with my angle on the outside, since it's not between the two sides. It's not an included angle between these two sides. For that reason, SSA does not work. It's not a valid congruency method for reasons discussed in class. And for that reason, I would say there is no good answer. I would write none. Since we were asked to state a postulate or theorem that can be used to conclude triangles are congruent, I would say there are none. There are no congruency methods that apply to this triangle because SSA is not a congruency method. All right. That is all for this video. See me again for the next page.